Hello everyone, May the 17th. Alright, let's do this. Maximum twin sum of a linked list. In the linked list size n, where n is even, the ith node of the linked list is known as the twin of the n minus 1 minus ith node. For example, if n equals to 4, then node 0 is the twin of node 3, and node 1 is the twin of node 2. The twin sum is defined as the sum of a node and its twin given a head into the maximum. Alright, so it's not really difficult if it's become an array, but it's difficult because it is a linked list. Basically, do they have any other requirements? There's no requirements. I mean, we can start, but then we can always just translate everything into an array and then just handle it there, but I don't really think that's the right way to go for it. I mean, what we can do, let's see what we can do. If we go from front, right, and yeah, it's like, it's mirrored, right? It's mirrored. So if we can go backwards, go backwards. I mean, we can, right? If we, let's say, turn the remaining into the opposite side. If we do that, then, like we set a head here, right? And then we turn everything to the opposite side, right? And then we start from the end, then we can kind of meet in the middle, right? This is what we can do. But I'm not sure if this is ideal, or do we want to do it that way? But if we don't do it that way, what are the other options? The thing is, I don't see other options. Because the pairing, right? The pairing is mirroring from the middle. So now one side has to go the opposite way. So short of just, copy everything into an array, I guess that is the only option. I mean, we can find this position easily. All right, that's not hard. We can find this position, and we just need to turn this one, right? We need to opposite this one, and at the end we can just turn it back if you want. But it's not satisfactory, right? It's not satisfactory. I'm hoping that we can just, like, say, go one way down and then, identify. But how is that possible, right? That's not possible. All right, let's just do it that way then. I don't like it, but that's probably the oh shoot, it happens again. It should be 17. We need to write the code, write a function to reverse a linked list. How do you reverse a linked list? Reverse, okay? So we have a head. And we'll return a list node. Right. How do we reverse? We get a head. Well, if I remember right, we always need to have a dummy, right? And we'll have two. We have a pre and a current. So pre is this, current is this. And we will always do, I think it's while current. We can say temp equals current dot next. And then we say current dot next equals pre. And what about pre dot next? Current dot next equals pre. And then temp hold on, I need to draw it. So we have, okay, so we have a dummy. All right, we have a pre, we have a current. So we have, say, this is a temp. I would say current dot next equals pre. Okay. And then current equals t. Pre equals current. And then t move on here. Current dot next equals pre. And then current equals t. Pre equals current. Pre equals current. Current equals t. And then t is going to be none. Okay, and then current dot next equals this. Current equals, now pre equals current. Current equals t. And then we're done. Now pre is the head, right? The new head. Pre is the new head, and this one, we're pointing to a dummy node. Which is fine, So in that case, I don't even need a dummy, right? I don't need a dummy. I do not need a dummy. This just could be a none, right? This, and now we say current dot next equals pre. Pre equals current, and current equals current dot current equals, so pre equals current equals temp. Okay, then we'll return the new head. Well, the new head will be pre, right? The new head will be pre. So that is to reverse. So now we just need to find this node. So we'll put a low, and we put a high, which works twice as fast, right? So high will go 1, 2, low go 1, high go 1, 2, and done. And low go 1. Yeah, high go 1, 2, low go 1. So I say a slow and a fast equals head and head. Okay, now I say while fast, fast equals fast dot next, slow equals slow dot next. All right, when I jump out, slow is the midpoint. Okay, mid equals slow. That's good. Then we're going to say tail equal to self.reverse mid. Okay, so self.reverse mid. So basically mid.next will be pointing to something else, which is fine. And now we have a tail. Now we can go from tail, go all the way down, from the front. Now we say res equal to 0. And we say front and back. Okay, front, back equals head and tail. While back, res equals maximum res, front dot val plus back dot val. And then front equals front dot next. Back equal to back dot next. Until back is exhausted. Then we can return res. Now we did not clean up our stuff. Now we probably should clean up. Clean up. How do we clean up? Now we need to reverse it one more time, which is using the tail, right? We're using the tail. Using the tail, which is fine. So we can just say self dot reverse tail. Okay. Let's give this a shot. Let's save it right. Ah. I am surprised. It might work. It does work. Huh. It does work. How did I solve it previously? The hell is this? Nah, come on. Come on, man. Don't do it that way. What's this? Oh. That was the... Oh, hold a second. That is different. Huh. Wait, what is this? Helper. Wait, hold on. Twin equals helper node on next. So we'll find the twin, right? We find the twin, and then we can get this. So for each node, this one finds you the twin. That's very complex. Wait, hold on, I didn't understand this. What was I thinking? So for each one, I will try to, I was using the stack, right? Twin equals helper, not on next. We're gonna find this twin, we're gonna find this twin, find this twin. Until we say we need to find node becomes slow, right? If node is equal to slow, then I think this slow means different from mine. This is probably the one before this cross point. So I do that, and I will return node on next on that. Will return that thing, right? We'll return that thing, which means the previous one will get that thing, and we'll return twin on next. Oh my god, how did I figure this out? This is quite some convoluted way to do this problem. Like, I don't know how I thought about this. Yeah, basically this is using stack. This is using stack to traverse backwards, basically, if you think about it. So every time we find a twin, we'll return twin on next. We'll return the next one, right? And you find the next one, right? You find the next one, and then every time you get your twin, right? You get your twin for a current node, you find your twin, and you'll return the next one. So that will be up the stack for the previous one. Oh my god. I like the current one. I like the current one. I don't know. I don't know what the official solution is, but this feels to me is better. I think it's better. 2130. So we reverse the second half of the linked list, find the max twin sum, and finally reverse the second half back. All right, what was the using stack? That was my solution, my earlier solution. Yeah. Reverse half, second half. Yep, that is the idea. But you have to reverse them back. Come on, you have to reverse them back. Yeah, that's true. How does the stack one work? Current stack. Current equals current on next. Blah, 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 blah. Wait. If you already did it this way. Nah. I don't like it. I don't like it. I'll stick with this. Okay, so this is done. Let's have some more fun. Number of even and odd bits. You're given a positive integer. Let even denote the number of even indices in the binary representation. Odd denotes the number of odd indices. Return the array where answer equals even and odd. The number of even indices. Okay, so that's nothing really. Yeah, just get it done. And make sure we don't make silly mistakes. Right? Even indices, odd indices. So the number, right? Rest shall equal to 0 and a 0. So even indices, odd indices. So for I, D in enumerate bin and, if I remember correct, I'm gonna say if it's odd. Oh, that's interesting. I mod 2, right? Plus equal to int d equal to 1. And I'll return res. That shall work. Wait. Why did I get 1, 0? It contains 1 on the 0th and 4th. It contains 1 on the first index. This is 1? Wait, what? What? This should be 0 position, right? Huh. Four probably not a good one. 8. 1 0 0 0. Huh. I think it's the opposite. Even indices in the binary representation. So I think it goes from right to left. Wait, this is weird. I need a confirmation. How about 1 0, right? If we do 1 0 1 0 0 1 2 3 0, yeah, what's this? 10. Yes. Yep. I think it's the opposite way. Dude. Opposite. Oh. Oh, fine. This. Right? If you want to go opposite, I just reverse it. Nah. That's probably not the right way. Hold on. Let's do this first and then reverse it. How about this? That works. That works. I don't know. It just feels weird when it says 0 indexed, right? The indexing for the binary representation is from right to left. Well, that's the only thing. I don't know how I feel about this. Feels weird. Two lines. Yo, that is smart. Oh, that is smart. Even. Odd. Holy crap, that is smart. That is smart. Oof. That is smart. I did not think about this. That is very smart. So since n, right, since n is smaller or equal to 1000, we can use bit mask to isolate, to identify the even and odd indices, either odd positions of n. So 1000 is at most 5, right? That's 2 to the 5. No, 2 to the 10. 2 to the 10. 2 to the 10 is 1, 2, 1, 0, 2. So we just need to have, we say even mask, right, shall equal to int. So we need 10 positions, even, so we have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, these are the even positions. And you can say odd mask is going to be 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we just need to say return even mask and we're gonna bing it, and then that'll count 1. Wait, it didn't say count 1, right? What did he do? Wait, where is it? Lord. I don't find it. Dude, I just like it. I was trying to see, did he use bin and then count? Ah, screw this. I think he doesn't use this count one. One liner. 2 lines here. Bit count. Oh. What the hell is bit count? Count a number for 1 bit. Oh, Python 3.10. Bit count. That's a new thing. Didn't know. So that bit count. And this shall be odd mask. Let's try it. Should try a larger value. Bit count. Good solution. Okay, that's it. I don't want to keep doing it. All right, I will see you guys tomorrow. Adios.